Okay, let's quickly go through what we had discussed in the last class. We had a gap of 3 days. Okay, fine. Okay, so last class what we discussed was effectively like how to solve questions based on projectile motion in 2 dimensions. We took slightly different type of questions. Other than the usual H max range type question, we took different questions where we found velocity at a certain height, angle made by velocity at a certain height, and such things. Okay, fine. So today we are going to discuss one concept, okay, called equation of path followed by an object. Uh, See, we are discussing motion in a plane, obviously. Plane is a two-dimensional geometry, okay, a flat surface, you can say. Assume there's an object moving in the plane of your screen. Let's say it started from some point here. Okay, this is the starting position, and this is the final position. One of you quickly tell me how many different paths are there for the object to go from A to B in this plane? How many different paths or routes are there for the object to go from A to B in this plane?
They're infinite.
Infinite. Okay. One is the shortest, that is direct from A to B straight line path. Okay, it could go like this. There are infinite paths, that is obvious. Okay, fine. I had told this before also, but can any of you tell me which physical quantities determine the way a particle moves? Based on which quantities about the, I mean, based on which quantities related to the particle, can you tell how it is going to move?
Magnitude and directions.
Of what? Which physical quantities about the object should you know to determine how it moves?
Mass.
Why do you need to know mass? Okay, let's see. We'll discuss that. Mass, okay. If you just know mass, can you tell how it is going to go from A to B? Okay, come up with some more answers. Someone said something, it was not clear.
Velocity, sir.
Nishita is saying velocity. Correct. This is more relevant. We had discussed this before also, that velocity of a particle or an object is what determines how fast it is moving and how, like in which direction it is moving, right? So how an object moves from one time to another time, or between an initial time and a final time, depends on its velocity. Okay. And velocity in turn depends on acceleration, how the object accelerates along the way. If there's no acceleration, it will move with a constant velocity. If there is acceleration, then based on the acceleration, magnitude of velocity could change, direction of velocity could change, it could change multiple times. We don't know. Okay. Saket, you said mass. How do you think mass determines how an object moves? It is a genuine answer only, but I want to know how, your reasoning. Like, how do you justify that mass determines how an object moves?
Because the greater the mass, the higher the resistance it is going to have in its movement.
Okay, correct, correct. That is exactly uh, how the motion of an object depends on mass. Okay, so yeah, you all have some idea of inertia depending on the mass. Like a light object means an object of less mass is easy to deviate. It's easy to accelerate. An object of greater mass, it's difficult to deviate or difficult to speed up, slow down, and all. Correct. But see, mass matters when you consider force. Because depending on force and mass, the object gets acceleration. In this chapter, we are dealing with acceleration directly. Now, you said it depends on mass, correct? How it depends on mass is force divided by mass gives you acceleration. Okay, ultimately it depends on velocity and acceleration only. Mass also will be used to find out acceleration. Okay, and in kinematics, we are not considering forces, masses to get acceleration. We are assuming we know the acceleration already. Okay, so mass was kind of already considered. The effect of mass was already considered in finding out the acceleration. Okay, so remember this, all of you. How an object goes from one place to another depends on its velocity and acceleration along the way. Okay, so based on the velocity and acceleration of an object, you should be able to tell what path it follows. Okay, starting from a certain point, from one time to another time. That is what we are going to learn in today's lecture. Let's take the first case, a very simple case of constant velocity. If an object has constant velocity, can any of you tell me what is its acceleration? If the velocity of an object is constant, what is its acceleration?
0, sir.
0. Correct. Correct. Okay. If acceleration is 0, velocity doesn't change. Reverse. If velocity is not changing, acceleration is 0. Now tell me, under constant velocity, in what kind of a path can an object move? With constant velocity, what kind of a path can an object follow? When I say what kind, I mean straight line, curve, circle, parabola. You use your imagination and tell me, or if you think it can go randomly also, you can tell, but think carefully and answer. With constant velocity, what kind of path can an object follow?
Just straight line.
Okay. Pawan is saying straight line. What about the others?
Circular.
Okay. So you're saying circle is also possible. Fine. We'll discuss. We'll discuss. Any other answers? With constant velocity, what kind of a path can an object follow?
Straight line, sir.
Straight line. Okay. Yusuf, what do you think? If an object maintains constant velocity, what kind of path can it move along?
Straight line.
Straight line. Okay. Listen, all of you. Velocity, by definition, is a vector quantity. Okay. Velocity is constant. That means speed is constant. It's neither speeding up nor slowing down. It maintains a steady speed. And velocity includes direction also. It's a vector quantity. So if velocity is constant, means both magnitude and direction of velocity are constant. So direction also does not change. Saket, now you tell me, is circle possible?
Possible.
Curved paths are not possible. Not just a circle. No curve is possible with constant velocity because direction is not supposed to change. And with constant velocity, object can only move along a straight line. Okay. Now, what we are trying to find out is the equation of the path followed. Now, with constant velocity, like by applying the physics that we know or by applying the everyday knowledge that we know, we could tell that the object is going to stay on a straight line. Now we have to derive the equation of that straight line. Okay, we are kind of making it mathematical. Okay, and you are required to know how to do this. Can any of you tell me the general equation of a straight line in the xy plane? What kind of equations represent straight lines? Or what kind of a relation between x and y gives you a straight line graph? That is my question. What kind of equation represents a straight line graph?
A linear equation.
Linear equation, correct. Can you tell how a linear equation looks, or can you give an example of a linear equation?
So y is equal to ax plus b.
Okay, y is equal to mx plus c, ax plus b. Fine. Okay. So if an object moves along a straight line in the xy plane, okay, see, they can specify which plane the object is moving in. It can be xy, it can be yz, it can be xz also. Any two coordinates should be there in a plane. Okay. Now they may not tell you that also. In that case, you can take the plane of motion as the xy plane. Fine. Suppose an object is moving on your screen. You can take your screen as the xy plane and write the equations accordingly. So assume an object is moving in the xy plane. If it moves along a straight line, then the equation will be of the form y is equal to, she said ax plus b. Generally, we write mx plus c, where m is called the slope, c is called the y-intercept. Okay. So it will be a linear equation. Okay. Now see, we are considering the xy plane, no? So the particle will have an x coordinate and it will have a y coordinate. And this effectively is a relation. Okay, the equation of path here, which is the equation of the straight line here, is effectively a relation between x and y coordinates of the particle. Fine. So what can you find out using this equation? Suppose this equation is known to you. Then for each x coordinate, you can tell what is the y coordinate. Means you can tell where the particle will be. Fine. So an equation like this is what we are going to derive. I mean, this is what we mean by equation of path followed. We need a relation between the x coordinate and the y coordinate. Okay, that is what we are going to do. Now see, I told you in the beginning, or you yourself told in the beginning, that how an object moves depends on its velocity and acceleration. So those things will be given to you, or you can find out from the given information. Its initial velocity and acceleration, you will be able to tell. Using velocities and accelerations, you should be able to derive a relation between x coordinate and y coordinate. Now that seems, I mean, they seem to be unrelated. If you are given the velocity of an object and acceleration of the object, how will you tell a relation between its x coordinate and its y coordinate? You can tell its you can tell its displacement, you can tell its position, but you have to relate its coordinates. Okay, what I'm saying is, suppose you know that the initial velocity of an object is some 20 I cap and its acceleration is let's say 5 j cap. Okay, initial velocity in meters per second, acceleration in meter per second square. Using these two, you can calculate the displacement if you want, ut plus half at square in a certain time. Time must be known. Okay. You can use v square minus u square is 2as. You can tell the final velocity also in terms of displacement, and such things can be done. But how to relate the x coordinate and y coordinates of the particle? Okay. So there is a very simple idea. Now, I told you at the beginning of this chapter, two-dimensional motion is a combination of two one-dimensional motions, one along the x direction, one along the y direction, which are independent of each other. They depend on time. Time to time, the x coordinate can change. Time to time, the y coordinate of the particle can change. Okay. So you can write displacement in the x direction is ux t plus half ax t square. This way you will get displacement in the x direction, and displacement is final coordinate minus the initial coordinate. Means final position minus initial position. We know that displacement by definition is change in position. So using this, basically what we have done here is we got x, that is the x coordinate of the particle, in terms of t, time. So we can tell its x coordinate at any time using a simple equation like this. But see, I'm not saying this is the only method to follow. Equations of kinematics are valid only when acceleration is constant. You all know that. Okay, I'm assuming acceleration is constant. Like in this example, I took it like that. So I'm just telling you there is a way. Fine. So writing an equation like this, we can relate its x coordinate to time. Similarly, writing an equation along the y-axis, uyt plus half ay t square. That is displacement in the y direction. Displacement in y direction is final y coordinate minus initial y coordinate. Using this, you can get y coordinate in terms of time. Fine. And if you know x coordinate in terms of time and y coordinate in terms of time, you can relate x and y. Okay. As a simple example, I tell you, not the solution to this problem, but generally, suppose x is equal to 4t and y is equal to 2t. Can any of you tell me how x is directly related to y? You need to eliminate t from these equations. Can you do it? If x is 4 times of t, y is only 2 times of t, how is x related to y?
The x is equals to 2 times of y.
Okay, how did you get that equation?
Sir, x by y.
You divided the equations. That is one possible way to do it. Correct. See, we need a relation between x and y. Means we have to put t aside. We have to remove t from these equations. So one way to do it is by dividing them. Divide, you get x by y is 4t by 2t, that is 2. So you get x is equal to 2y. And look, see what you got. You got a relation between x and y. That's what we were looking for. Okay, that itself is the equation of path followed. Okay, basically, see, the path followed by an object will be a graph, no, on the xy plane. You have to write an equation for that graph. If it's a straight line, you have to write the equation of that straight line. If it's a parabola, you have to write the equation of that parabola. That is what we mean by equation of path followed. Every path basically is like a graph on the xy plane, and every graph has an equation associated with it. That equation is what we are trying to find out. Okay, so this is one way. You can just divide them. Otherwise, from the first equation, x is 4t, that means t is x by 4. You can put that in the second equation. Like take t from the first equation and substitute it in the second equation. Then you get y is equal to 2 times of t, that is 2 times of x by 4, that is x by 2. That way also you get x is equal to 2y. Same equation. Okay, so it's just simplifying equations. So listen, remember this procedure. If you ever want to find out the equation of path followed by an object, first, the physics tells us that how an object moves depends on velocity and acceleration. From where to where exactly it goes depends on where it started from also. So you need to know where it started from. That is the initial coordinates. Let's call it as x naught, y naught. You need to know where it was initially. You need to know its initial velocity. And you also need to know its acceleration. Because acceleration changes velocity, no? And velocity is what decides how the object moves. So you need to know these three terms to tell the exact equation of the path followed. Okay, that is what physics tells us. Next, the mathematics part. How to do it? Suppose these three are given also. What can you do to get the equation of path followed? Remember that any equation, any path followed, not equation, any path followed, okay, be it this first path or this second path or this third path, effectively it's a graph on the xy plane. You need to derive an equation which represents that graph, which represents that shape. Exactly. Okay. And the equation of a graph on the xy plane is basically a relation between x and y. So what we are looking for is a relation between the x coordinate and y coordinate of the particle. That is what we mean by equation of path followed. Okay. Now with initial position, velocity and acceleration, how to get the relation between them? Use whatever equations you have to find out displacement first along the x-axis and along the y-axis, like this and this. Once you know displacement is change in position, right? In that you will have the final position x and the final position y. So your aim will be to get displacement as a function of time or anything. Okay. Displacement along x-axis, you have to write a function. For displacement along y-axis, you have to write a function. Then relate them. I mean, you can divide them, or you can take t from one equation and put it in the other equation. Do whatever. You have to eliminate other variables and get a relation only between x and y. That will be the equation of path followed. Okay, that will give you the mathematical equation of the exact shape that the object is moving along. Fine. Let us try it in one case. I'll give you a simple question. Let's say the object is initially at say 2, 4. Okay, it's not at the origin. When the observer started observing it, it was at this position 2, 4. And assume it was moving with a velocity of, how much shall we take? 3 I cap plus 2 j cap. That is its velocity. And it didn't have any acceleration. First, tell me, using the physics that you know, if acceleration is not there, how would the object move? I mean, what kind of path would it follow?
Straight line, sir.
Straight line, constant velocity, straight line. Okay. So in this question, the question is to derive the equation of path followed. Okay. If you derive the equation of path followed by this object, how is the equation going to look? You know the path is going to be a straight line. So I'm asking you, how is the equation, xy equation, going to look? Anyone, how will the relation between x and y be when it represents a straight line, when the graph is a straight line? It's a linear equation, okay? It has to be of this form. Y is equal to mx plus c, or it can even be like this. Ax plus by plus c is equal to 0. Here also the powers of x and y are 1. This is also a linear relation only. Fine. So you should get an equation of this form. Fine. Try this, all of you. I'll give you some steps also here, since this is the first question. Acceleration is 0. 0 is a constant only. You can use equations of kinematics. So what I want you to do is write an equation for displacement along the x-axis and equate it to final x coordinate minus initial x coordinate. Initial x coordinate is given on your screen. You can use that. From this, you get x in terms of t. Do the same for y also. Displacement in the y direction is equal to, write the equation here. That is final y coordinate minus initial y coordinate. And from that, you get y in terms of t. Once you do that, eliminate t from the equations. To relate x to y. Do this, all of you. I'll give you 2 minutes. I got only one answer so far. 3y is equal to 2x plus 8. We'll see. Okay, another same answer. Good. Okay, let us discuss. Aishwarya, can you unmute?
Yes, sir.
Huh. Can you tell the displacement equation for along the x-axis? Like when acceleration is constant, how do you write the displacement as a function of time?
Sir, it's ut plus half at square. Since acceleration is 0, it will be 3t, sir.
Okay, good. Only velocity into time. So ut plus half at square. Half at square term is going to become 0 anyway. So displacement along the x direction is 3t. So you can say 3t is equal to x minus x naught. Aishwarya, what is the initial position along the x-axis?
Sir, 2.
2. Correct. So tell me, what will x be in terms of t? Like we got 3t
So
is.
t is
Go ahead. Go ahead.
so t is equal to 2 minus x by 3.
It is x minus 2. No, how can you change it to 2 minus x? Like here, you effectively got, like there is 3t on the left hand side. There is x minus 2 on the right hand side. So 3t is equal to x minus 2. So t is equal to x minus 2 divided by 3. You can't make it 2 minus x. Okay. Or you can send the 2 that side. You get x is equal to 3t plus 2. Okay, that is x as a function of time. Look at this once again, all of you. If any of you has a question or doubt, you can ask. Till here. Okay. Saket, you tell me now. How do you write the displacement in the y direction?
2t, sir.
Okay, velocity in the y direction into time plus half a by t square. That term is 0 because there is no acceleration. So this is 2t. What was the initial y coordinate?
4, sir.
4. So how do you write y as a function of time?
Two t plus 4.
2t plus 4. Correct. Okay. So one equation we have is x is equal to 3t plus 2. The other equation we have is y is equal to 2t plus 4. Now see, dividing them is not a good idea. We can't eliminate time just by dividing these. One thing we can do, you can write x minus 2 is equal to 3t and y minus 4 is equal to 2t. Dividing these two can help you cancel t. Okay. And what will you get? X minus 2 divided by y minus 4 is 3 by 2. Now cross multiply. 2 times of x minus 2 becomes 3 times of y minus 4. Okay, I'm doing it very slowly, step by step. If you practice a little bit of mathematics, solving equations and all, you'll be able to do it much faster. So 2x minus 4 is equal to 3y minus 12. That's all. You can send the 12 this side if you want. So 3y becomes 2x plus 8. Or you can also write y is equal to 2 by 3x plus 8 by 3. I am writing it like this just to show you that it is in the form y is equal to mx plus c, which is the general equation for a straight line. Okay, this is also a general equation only, no problem. Okay, it all depends on how they give you the options. Okay, how you write the final equation, you have to check from the options and decide. So hope this is clear to all of you. And let us also visualize the actual path along which it moves. The initial position is 2, 4. We know the initial velocity also 3 I cap plus 2 j cap. See, initial velocity 3 I cap plus 2 j cap looks like this. 3 I cap is this way. 2 j cap would be this way. So the velocity of the object is in this direction. 3 I cap plus 2j cap. It moves like that. Okay. Let us visualize its motion on the xy plane. Okay, this is not necessary. The point where it's starting from 2, 4 is in the first quadrant, and its velocity is also pointed like this. You can see how the velocity is inclined, so it continues to move in the first quadrant. So taking the first quadrant will be enough. Two, 4. So maybe this is where it started from. And its velocity, I'll copy this vector as it is. I'm just making it shorter without changing the direction. So its velocity is directed this way, and the object keeps going along that direction. So what we derived is the equation of this straight line along which the object moves. Okay, it doesn't look like a straight line. I drew it with free hand, but it moves along that straight line, whose equation is given by y is equal to 2/3x plus 8/3. Okay, that is what we mean by equation of path followed by an object. Are the steps clear to all of you? Okay. Let's try one more question. This time with acceleration, but I'll make it slightly easy. We'll assume it started from the origin. Let's say initially the object was at 0, 0. Its initial velocity is 4 I cap plus 2 j cap meters per second, and its acceleration is 2 I cap plus j cap meters per second square. Look at the velocity and acceleration and tell me, any of you, if you see a relation between them. Do you find any relation between those two vectors?
Sir, velocity is twice of acceleration.
See, velocity has components 4 and 2. Acceleration has components 2 and 1. It's like velocity is twice of acceleration. As a vector, if you see, actually you can never say a velocity is twice of an acceleration. But just the vector part, if you observe, velocity vector is 2 times the acceleration vector. Now generally tell me, if a vector is 2 times of another vector, is there any relation between their direction? If one vector is exactly twice another vector, is there a relation between their directions? Or could they be in any direction and still be written A is equal to 2 times of B?
So they are moving in same direction.
Don't say moving, they are pointing in the same direction. Correct. See, if one vector is twice of another vector, it's like, see, this 2 is a scalar, positive scalar, right? So when you multiply B with a positive scalar, you are getting A. A vector B, when multiplied with a positive scalar, its direction does not get changed. Okay. So here also, we are seeing that numerically, initial, like as a vector, initial velocity is twice of acceleration. That means initial velocity and acceleration are in the same direction. You can even prove it mathematically. See, initial velocity is 4 I cap plus 2 j cap, no? 4 I cap would be like this, plus 2 j cap would be like this. See, all this will help you visualize the situation correctly. Okay, and you have to do this. Physics questions, don't solve them mathematically. Okay, only if you understand the situation properly, it will make more sense, and it will, what can I say, stay in your brain longer. You need to exactly understand what is happening. So yeah, 4 I cap plus 2 j cap. Let's say this vector makes an angle Alpha with the x-axis. Someone quickly tell me how much is tan alpha?
Y component by X component.
Okay, in this case, how much will that become? Opposite by adjacent.
1/2.
2 by 4, that is 1 by 2. So the angle alpha that this velocity vector makes with the x-axis is tan inverse of 1 by 2. Correct. Now let us consider the acceleration vector. Acceleration is 2 I cap plus j cap. No. Now if that is 4 I cap, then 2 I cap would be half of it like this. Same direction, but exactly half. Maybe somewhat like this, 2 I cap plus j cap. If that is 2 j cap, then j cap will be like half of it. And we'll draw it here. Just so that we complete the triangle. Okay. So 2 I cap, j cap. Then this is the acceleration vector. Let's say it makes an angle beta with the x-axis. Someone other than Vanilla, quickly tell me tan beta. Only j cap means 1 j cap. How much is the
Beta is equals tan inverse 1 by 2.
same thing again? Tan beta opposite by adjacent 1 by 2. So you get beta is equal to tan inverse 1 by 2. Okay. So alpha and beta are the same. Means the inclination of initial velocity vector and the inclination of the acceleration vector are the same. Means they are pointing in the same direction. Okay. See, generally, not just for this question, generally, if there are two vectors having the same ratio for all the components, ratio of x components is equal to ratio of y components. In 3 dimensions, you'll have a z component also. If all the components are in the same ratio, then the vectors will be parallel or exactly opposite to each other. When will they be exactly opposite? If the ratio is negative, means minus 2 I cap minus j cap. Suppose this was the acceleration. Then you see velocity to acceleration, x components are 4 and minus 2, means ratio is minus 2. 4 divided by minus 2 is minus 2. Okay. And y component ratio, if you see 2 divided by minus 1, that is also minus 2. Okay. So if the components have the same ratio and that ratio is positive, then the vectors are in the same direction. And if components have the same ratio and ratio is negative, vectors are exactly in the opposite direction. Okay. This is another way which, this is an idea which will help you visualize how the object is going to move. You can comment on how the object is going to move. Okay. Let's take one example based on this idea first, then we'll come back to this question. Are these vectors in the same direction? Are these vectors pointing in the same direction? You can use the ratio idea, or if you are comfortable with visualizing angles, find out the angle made by the first vector, find out angle made by the second vector, check if the angles are equal.
Yes, sir.
Okay, we'll see. Yusuf, can you tell, are they pointing in the same direction or not?
Yes, sir, yes, sir.
How did you verify?
So, J cap is in positive, no, sir. J and I both are in positive X and Y. So 4 I cap is right side, and then 8 I cap on top. So then the tan, so what do you call it, sir? So it's pointing in the right top direction.
See, But still, one could be like this and one could be like this, no? Pointing to the right, tilted upwards. How do you decide that they are exactly tilted at the same angle? What mathematics did you use? Just because the numbers are all positive doesn't mean they are parallel. How do you calculate the angle made by the angle between the vector and the x-axis? Like the first vector, let us take 6i cap plus 12j cap. The vector will be like this. How do you calculate this angle alpha, Yusuf?
So tan alpha.
How much is it?
So 2/1.
Okay, correct. Then for this second vector, you visualize x component is 4i cap, y component is 8j cap. What angle does the second vector make? Or what is tan of that angle, beta?
2/1. Same.
That is how you decide that the angles are same. Since tan alpha is same as tan beta, alpha should be same as beta. Okay. So not simply because all components are positive. So you find out the angles which the vectors make. Or as I said, there's another thing you can do. Divide the x components. 6/4 is 3/2. Next, divide the y components. 12/8 is also 3/2. That means ratio of x components is same as ratio of y components and the ratios are positive. So ratio of x components are equal to ratio of y components and that ratio is positive means they are parallel vectors. They point in the same direction. Had the ratio been negative, you can tell that they are anti-parallel vectors. You find out the angle, you'll see it will be exactly opposite to the first vector. Okay, you draw the vector and see, you'll see that second is exactly opposite to the first. So this is how you tell whether vectors are parallel or not. Fine. Now let us solve this question. We are still dealing with equation of path followed by an object. Yeah. Now you observe the initial velocity and acceleration. Ratio of x components 4/2, it is 2. Ratio of y components 2/1, that is also equal to 2. So ratio of x components is equal to ratio of y components and that ratio is 2, positive number. Means these are parallel. Parallel means what? Same direction. Okay. Why are we even concerned with whether they are in same direction or not? Because see, we are dealing with physics. It'll be better to visualize the situation. Now one of you tell me, if initial velocity and acceleration are in the same direction, how does a particle move? Particle or an object?
Straight line, sir.
Straight line, correct. So in this case, when you derive the equation of path followed, what kind of equation do you expect? A linear equation must be derived. Y is equal to mx plus c again. It should be of this form. Start solving, all of you. You know the steps. You have to write displacement in the x direction and get x coordinate as a function of time. Okay. Then you have to write displacement in y direction and get y coordinate as a function of time. Then relating, like by dividing them or taking t from one equation and putting it in the other or doing whatever, you have to get a relation between x and y. Try this, all of you. I'll give you 3 minutes. Okay, I got two answers as x is equal to 2y. We'll see. Nishita, can you unmute? We'll discuss.
Yes, sir.
Have you written, like, did you get x coordinate as a function of time? Or, okay, tell me, how will you write displacement in the x direction? Generally, when acceleration is constant, how do you write displacement in terms of time?
S is equal to ut plus half at square.
Correct. So if you want only in the x direction, then you take uxt plus half axt square. How much is ux? X component of initial velocity?
4.
Correct. So ux t plus half. How much is ax? X component of acceleration?
2, sir.
2t square. Okay. So that becomes 4t plus t square. And this is displacement in the x direction. And we know displacement is change in position. So you write this as final x minus initial x. Where was the object initially according to the problem?
0.
0. It was at the origin. So x minus 0. Therefore, you get x is equal to 4t plus t square. That is x as a function of time. Okay. Yusuf, can you tell displacement in the y direction? Or Aishwarya, can you tell? Fine. See, we have to write uyt plus half ayt square. Uy, initial velocity's y component is 2 plus half ay, acceleration's y component is 1 t square. That is 2t plus half t square is equal to displacement in y direction means final y coordinate minus initial y coordinate. So you get final y coordinate is equal to 2t plus 1 by 2 t square. Okay. Now we got x as a function of time, we got y as a function of time, and now we need to relate x and y. And it's quite easy if you observe, there is a relation directly between them. 4t plus t square means 4t plus 1t square, 2t plus half t square. You can directly tell that x is 2 times of y. Or you divide these equations. If you divide them, you get x by y is equal to 4t plus t square divided by 2t plus half t square. In the numerator, you take 2 common. It becomes 2t plus half t square divided by again 2t plus half t square. This part can be cancelled. So x by y is equal to 2. That means x is equal to 2 times of y. Or you can say y is 1 by 2x plus 0. So we again got it in the form y is equal to mx plus c, proving that it indeed moves along a straight line. As expected, if we first checked by looking at the vectors, we could tell that initial velocity and acceleration were parallel to each other. Parallel to, if velocity and acceleration are in the same direction, the object must maintain its direction. It should go in a straight line. And that is what the final answer is telling us. Okay. And see, just to solve problems quickly, if you know that velocity and acceleration are in the same direction, then it will maintain the direction of velocity. No, without considering acceleration also, you can tell the path. How does it matter whether it speeds up or not? The path is determined by velocity. Direction is not changing, that you have decided. Since velocity and acceleration were in the same direction, object's direction doesn't change. So just by using velocity, you can tell the path. You don't even need to use acceleration. Right? That shortcut you can use sometimes if you are sure that the path is a straight line. Okay. Let's try one more case quickly. Do this on your own, all of you. Again, assume the initial position of the particle is the origin itself. Initial velocity is some 4 I cap meters per second. Acceleration is, say, 2 j cap meters per second square. Let us visualize this first. Can one of you quickly tell me 4 I cap is in which direction? Four I cap is which way?
Positive x direction.
Positive x direction. So the object is at the origin and it is moving in the positive x direction. Okay, it was moving like this. At least at that position, when it was at the origin, it was directed that way. Okay. 2 j cap is in which direction?
Positive y direction, sir.
Positive y direction. Means the acceleration is this way. We know that force gives acceleration. Okay. So an object which is moving to the right, or you can call it as eastward direction. This is the northward direction. An object which was moving towards east is pushed by some force towards north. How do you think the object will move? Will it continue moving in that straight line towards east? Anyone? Will it continue moving purely towards east?
No, sir.
Definitely not. Okay, you can just imagine a ball going this way and you strike it in this direction towards north, or you can imagine a paper ball going this way, you blow air towards north, then it will deviate from its path, no? Or you can tell this way, acceleration is in the y direction. Y component of acceleration disturbs the y component of velocity. Now, the particle didn't have a y component of velocity, but because of this acceleration, it is going to gain a y component of velocity. And what happens to the x component of velocity? Nothing, because there is no acceleration in the x direction for this particle. So how this particle is going to move going forward is that the x component remains the same, the y component continues to increase, means it starts moving in the y direction. So at the next moment, it will deviate from its path somewhat like this. It will be here. And it will have the same x component of velocity there, but it will now have a small y component of velocity, which it would have gained due to that acceleration. So effectively it moves like x component, y component, resultant velocity will be in this direction. At that moment, it's directed like this. But acceleration continues to act, means the y component continues to grow. Then at the next instant, let's say the particle moves to this position, the x component remains the same, y component grows further. Okay, y component increases. And if x component remains same and y component increases, the vector is going to tilt upward. The velocity vector will tilt upward like this. Okay, so effectively the velocity vector keeps on tilting upward and the object follows a curved path like this. It will no longer be a straight line. Now we have to get an equation of that curved path. Same steps, write x coordinate as function of time, y coordinate as function of time, remove time from the equations. Do it quickly, all of you. Acceleration is constant, you can use equations of kinematics. Okay. I got two answers as x square is equal to 16y, and I got one answer as x is equal to 4 root y. It's the same thing. Okay, fine. Listen, all of you, I'll explain this quickly. First, we'll write displacement along the x direction. Initial velocity along x direction is 4. So uxt plus half. Acceleration in the x direction is 0t square. So that's only 4t. And that is displacement in the x direction. Final x minus initial x. So we can say that x is equal to 4t. Next, along the y-axis, uy is 0. So ut plus half. Ay is 2t square. So that's only t square. And this is displacement in the y direction. So final y minus initial y. Initially, both x and y were 0. Okay. It depends on that also. So you get y is equal to t square. Okay. X is equal to 4t is one equation. Y is equal to t square is another equation. This time, if you divide, there will be no use because the power of t in one equation is different from the power of t in the other equation. So dividing cannot eliminate t altogether. You need to make the powers common and then divide, then it can help. Okay. But simply take t from one equation and put it in the other equation. From the first equation, you can say t is equal to x by 4. Substitute that in the second equation. You get y is equal to t square. No, t square means x by 4 whole square. That's all. So y is equal to x square by 16. Can any of you tell me what is the exact shape represented by this equation? It's definitely not a straight line now because the power of y is 1. The power of x has become 2. So it's not a linear equation. It won't be a straight line as expected. What will it be? What shape?
Parabola, sir.
Correct, correct. See, y is equal to x square by 16 is a quadratic equation. And quadratic equations always represent parabolic graphs. Okay, so the path followed by this object is actually a parabola. And there is something interesting. Last class and the class before that, we discussed a lot about projectile motion, right? In 2 dimensions. And we know that path is not a straight line. It looks like a nice curve concave downwards. It looks like a parabola. So I'll send you a worksheet tomorrow. In that worksheet, you will be deriving the equation of this path. Means, see, what we have discussed today is all mathematical. Means I gave you some initial position, some initial velocity, some acceleration. Based on that, you derived. Let us apply that knowledge to motion under gravity. So we'll take some initial velocity, but we'll take acceleration as acceleration due to gravity and derive the equation of path followed. We'll see if it's a parabola. If it's not, it could be something else also. But this is what you are going to have in your next worksheet, which I will send tomorrow morning. And tomorrow is what, Saturday, and then you have Sunday also. So yeah, tomorrow's worksheet will be a bit lengthy. And I want all of you all to send answers by Sunday evening. Tomorrow's worksheet is compulsory. Okay. So you'll be deriving the equation of path followed by this projectile, which is projected under gravity. Fine. And in that worksheet, you'll also have some questions. See, hints will be given. Worksheets are not difficult to solve. It's just that you need to spend some time with the subject. Okay. That is why I'm giving you worksheets. So equation of path followed by a projectile is what you will be deriving. That's one thing. And the second one is, till now we have only discussed ground to ground projectile. Okay. In the worksheet, you will have some questions where an object is projected horizontally, it falls like this. And another case, like from a certain height itself, it is projected obliquely. So it goes up for some time and then comes down. You'll have questions based on these cases. Hints will be given, steps will be given. Just follow the steps and derive the results and send me your answers by Sunday evening. Okay. Fine. So that is all for today's class. So let's quickly go through what we discussed. We learned how to derive the equation of path followed. I'm not saying this is the only method available, but this is the most frequently used method. Equation of path means a relation between x and y. And how are we doing that? We are writing x as a function of time, y as a function of time, eliminating time, so that we can relate x and y. Okay. So before deriving the equation, we did a bit of visualization, how we expect the path to be. If it's a straight line, we expect the equation to be of the form y is equal to mx plus c. If it's a curve, then it should not be a linear equation, which we saw in the last question. It's not a linear equation. We found that it's a parabola. Okay. Fine. We'll continue on Monday. Thank you all.